Today we're going to talk about competing risk, and for the competing risk, here is the model I'm interested in. Is basically, if I have, say, here are the world leader, and then they're going to get out of power through three different conditions, and then we're going to try to figure out that, okay, what variable under different region can be most likely modeled in certain way. So let me run the program first and then show you what the model can be used for. Okay, so first the data steps. And here is on page 189. Input years, and how many years in power, lost due to what reasons and manner, and how they get power, all the variables, and so on. And I have all the grow leader like this, and and you can just first run the proc means, figure out, okay, I have this many leaders, and they have on average how many years in power, lost power, all the variables that I mentioned. So here you have the same things, number of years in power, every variable explained. Okay, so proc means basically give you all the observations, minimum, maximum, and so on. Okay, and based on this, okay, you can consider the following, and this is the part we're taking advantage of. This is so there are world leader in different regions, and just consider that you're an international company or you work for United Nations. You have this different business in in different area, and you don't want your business bankrupt, right? You don't want to get kicked out or get sued or something, and lose your business. And so you can do stuff like, for the world leader to stay in power, maybe is give them more education, and maybe for a constitutional type of country, you want to give them more education, because people, the more they know about you, the economic is growing, and they probably will vote for you again and again. And on the other hand, if you are a dictator, you're in a very democracy deprived area, you don't want to give people education. So if you run this in different region for different reason, then the model becomes the following. Okay. This time, you basically do the same things, and you do a live test, okay? And you can plot them one by one. And like I said, you plot, if you censor 0, 1, 0, 2, 3, means that you're interested in region 1. The last, the reason 1, and then 0, 1, 3, you're interested in reason 2 and reason 3. And then you can plot them, okay? And you can deal with the EFROM on different situations. And for this one, I just want to first show you, oops. So this time you'll have different loss function for different groups, and you can plot the the loss function, and you can plot the history. And for example, if let's just say that we agree they are significant model, can you use proc live regression and find a parameter and then plot the model them as different parameter and figure out a CVAR? You can do the same things again. Agree? No, because you have a you can do it in Excel. You can do it in but in this case, what is the real interest here? You think if we doing the PHRAG, basically insurance company basically need to decide the following things. If you're talking about a policy or a business, okay, one is that if you're going to get out of business because of your reliability is low, what would be your way of doing things? Is that you try to find, let me reinforce certain things in certain way. For example, for a car company, what can they do? They can have a recall, right? If they realize that they have certain reliability issue or certain things, they say that, whenever they have their growth, or their population under certain rate, they tend to have problem. Then how to increase the number of user? For credit card company, what they do, they issue the credit card to younger people. They can always do something to change their rate. So if you read the plot here, for example, would you agree with me? Look at the plot in the books on page 192. Maybe just by looking at this, group 1, outcome 1 and outcome 3 are very, very similar, right? And outcome 2 is somewhat different. And you can use the hazard model to plot it and try to get the same things, compare them. And the questions here is, if I have two set of policy, okay, one for group 1 and group 2, outcome 1 and outcome 3, and outcome 2 single out by itself, what's the benefit? You only need to worry about two different type of policy. You don't need to come up with, two warranty, more, if I can have 3 warranty versus 2 warranty, it's easier to manage if I only have 2 groups of warranty. So the question really become, do I really want to have 2 warranty or 3 warranty? Okay, and if, for example, I want to come up with only 2 warranty, okay, how do you do that in this code? Let me go back to this code. It's basically do the following. So you program 2, no matter lifetime, all the subtraction addition here, this part of the IML, just try to make the computation looks nice, so you can ignore that. But what is important here is this, okay? If, okay, we just said 2 is the group we want to use, right? And then 1, 3 is the other one we want to use, right? So how to merge them into only 2 groups? So all you need to do here is 0 and 2 is sensor. That means 1 and 3 I consider a similar problem. You follow me? So now group 1, outcome 1 and 3 will be in 1. And then, so 0, 1, 3 for 02. So 013 will be the one outcome I'm worried about. 2 is the other one I'm worried about. And do you need to do this 012? You don't need that one anymore, because you can only you don't need to worry about this group. So first things first, if I only want you to worry about group 0 this way, and we'll basically remodel this whole things. Rather than having 3 groups, we only have 2 groups. Okay? And what will dictate this is the following. If you merge them into one policy, and you say that, okay, you work for United Nations, okay? And so here we have to count how many customers in group 2, how many customers in group 1-3. And they said that, oh, for group 1-3 leaders, now we're gonna go back and say that, oh, all the educations, okay? Here, the education is, let me go back to here. Where is the educations? Population, literacy level, and literacy and region, okay? So if I copy the data set here, okay? Data, text to column, and delimited using space. Finish. Okay, so we know that the last one is the column L is education, right? Is the literacy, right? 1, 2, 3 is the region. Agree? So now if I play the game and basically said the following, okay? If let's go back to where is the loss power? Loss is the manner of losing power, right? Loss 0, 1, 2, 3. Agree? And we said that we're going to make 2. One group, 1, 3 as another group. So if I'm here saying that if this guy's, okay, column number 2 is losing power, okay, if you are 2, or B1 equal to 1, or B1 equal to 3, okay? So first thing first, if there are 1 or 3, so let me do a couple more. See here, this is 1, this is 3. So if there are 1 or 3, then if this is true, then the educations, okay, here need to plus 2. Say I give, if you belong to region 2 or region 3, I give you 2 more years of education, okay? And then if you're otherwise, okay, leave it as it is, okay? So now you can see that the educations increase or decrease because of you're losing power in a certain way. So what are we trying to do here? Is saying that, you're losing power because of 1 and 3. Let me give your people more education and see if I can shift the CVAR or the curve a little further to the right? The risk ratio will reduce, and then do something there. That's nice, right? So technically, what we should see is that by adding more education, maybe you can drop the death rate or the losing power rate. But the problem is that giving them more education is free, or you need to pay price. You need to pay price. 2 years education, you need to add 2 more years of student loan, right, to your budget. Or you need to find the money somewhere else. So there are just things going on is that, I would like to have a recall or do something about it to improve my reliability of something, to reduce the ratio of something. But every time when you do that, you need to count how much money you have to spend in order to do that. So now it becomes what kind of comparison? A lot of time is adding education is a cost for the total expected cost you're going to spend. And then you ask, how much CVAR can I gain because of that? You follow my argument? And the thing is, if I can do that for education, can I do that and say that, you only do that for the education? So let me insert this one more time. Okay, so here's the part I would like to give you is since I'm not teaching SAS directly, so I prefer using this approach to show you Excel is easy, see and done. Now, let me give you a challenge here. What if, okay? So this statement right now is saying that if you're having literacy increase for 2 years, I'm only doing it for those who are gonna potentially lose power due to 1 or 3. The second things I can do is the following, okay? What if, so this is add education. So I will have a new education, so I will have a new literacy. Number, to compare with by adding more literacy to, so I change the literacy from this value to this value, okay? And obviously you can see when you're gonna have the change. Equal to 3, this is a new one, right? And no change here. And change here, right? Because it's from region losing power 1. And here for losing power 3. Agree? You see the differences? Yeah. But now let me give you another challenge. What if I said that, I have several regions, right? I have several regions. I have region, let's go back to the books. I have region 0, 1, 2, 3, 4, okay? And I'll say that adding education in, well, could be case if we're talking about East Asia from Korea, Japan, Taiwan, Hong Kong, what's the things in that area? They already overeducated. The number of years of education, is really, really high. So I would say that, but if it's in that area, I don't want to add more education. I only want to add education, say, for Latin America and Africa. So if it's in Asia, no, you don't want to add more. If it's in North America, you don't want to add more. So 2 and 4, you don't want to add more education. But if it's region, well, let me make the problem easier to talk about. If it's in Africa, I want to add, originally we have 4 years of education, right? 2 years of literacy to improve the situation. What if I said that if it's in Africa or in Latin America? In Latin America, I add 2 more years. In Africa, I'm going to add 4 more years. Okay? So do you think that's possible in a company's policy and said that, oh, we're going to double the service or double the on-the-job training, whoever using our products. But if we're going to do this in Asia or do it in certain area, we don't need to give extra training. But in certain area, in order to keep our equipment fully functional, we need to provide extra training. Is that possible? Yeah, so the next things becomes same things, is that how to reduce the risk ratio. I can say that, okay, if it's a region 1, I add 2. If it's a region 2, what did I say? Region 1 and region 3. Okay. So how to change this statement? So now you can add one more and said that if the region M1 equal to 1, I add 2. No, I add 4. Okay? Otherwise, okay? M2? Yeah, okay. Oh, M2, yeah. Okay. Okay? Otherwise, I leave it as it is. Okay? Oops. How come I get, oh, I add 4. If it's from region 1, I add 4. Okay? And I can do the same things. Copy this whole things, redo it again. I don't know what I did. Okay. Okay. And if in region 3, I add 2. Okay. And Control C. And let me just copy this. Okay, So see here, region 3 add 2. Region 1 add 4. We already see that, right? Okay. So now this is a new literacy for 1 for Africa, and this is new literacy for South America, Latin America. Now the problem is you want to change this in one shot. So how to do that? If I said that, oh, I would like to have a policy, what you can do is do this, equal to this minus this plus this minus this, okay? And that is the 4 more years, right? So all you need to do is do this and plus the literacy back, okay? So now what you will have either, okay, this is, let's see. Something is wrong. We can either, if M4 equal to 1, region 1, I add 4 years. Otherwise, I'll leave it as it is. And region M equal to 3, I add 2. Otherwise, I leave it as it is.
Do you want, like, if B5 was 1 or 3, and then add in 5 equals 3?
Say that again.
So what you're trying to say is like, if it's B5 is 1 or 3, and M5 is 3. So right now you have or B5 equals 1, B5 equals 3, and M5 equals 3.
No. Let me figure out what did I do wrong. Because this one is okay. We only care about losing power in 1 and 3, right? And then so both are losing power 1 and 3. But this one is losing power 1 and 3 if it's in region 1. Then I give 4 more years of literacy. Right? Yeah. And this is if it's in region 3, then, oh, I shouldn't use or. You're right. Yeah. Okay. So, one more time. Or here. And then I need an end statement on top of end statement. I need another parentheses. Oh, I need a comma. Oh, I need a comma. Okay. So, and this one is something or and M2 equals 3, I got extra parentheses? Okay. Okay, oh, now I see what my problem. I put a parenthesis rather than, I put a, yeah, okay, let's now try this. Okay, let's see if we got it right this time. If is losing power 3. So I'm losing power 3, and I'm in region 1, I add 4 more years. And if I'm in region 3, I'm in region 3, I'm losing power 1 or 3, I add 2 more years. I got it right this time, right? Okay, so finally I create a new variable called new literacy. And this time the new literacy becomes, well, I can write it really short, as just like this. Okay, but let me show you this. Is the same, basically it's saying that if there's no change, right? No change, add a 20, you maintain the same. But if you're making the change, so here, let's find a couple, okay? The final is this one, and original is this one. So let's compare the two green region. So here, 86 become 88 because it's from region 3, and then it's losing power 1. So this is the new variable. And let's do another one. 96 from region 3, and here if it is losing power 2. Okay, if it's losing power 2, this is wrong, because by definitions, losing power 2, I shouldn't I only pay them as either 1 or 3, right? And this one is 2. And how come I'm still paying? Oh yeah, I didn't. So we're good. So here if it's a 2, I didn't spend any money. And so now the PHREG, it becomes a accounting, but this accounting is very, very different from the CVAR accounting. The CVAR accounting is an individual accounting. I have a policy and said you follow this distribution. And then I have a VAR cut. And said I'm gonna check by this time. I'm gonna check after 200 weeks. I'm gonna check after certain VAR criteria. And I wanna see how much the I3 region left. And depends on each individual. Okay? And that kind of operation is, I'm basically, what kind of insurance you want to buy? And I can tailor based on your need, one by one. Okay? But PHREG in a competing risk model, a lot of time is kind of like a quick and dirty operations. And basically said that, I would like to cut down the certain problems. And then just say that, okay, I'm gonna only give this to certain people, because if I give it to other people, not gonna make any major risk ratio changes. You follow me now? So the game here is, after you do this, okay, you can come up with a, what I will do is I will copy this. This is a new literacy curve, and then I will paste value back to this. So now I have a new education literacy score, and and then by using the new literacy score, I go back to my data, and run the whole thing again, and basically see how much I can change because of the risk ratio. You follow me now? So PHREG for competing risk, I consider that as the engineering approach. Oh, for this, I will give you discount. For this, I'll give you extra credit, buyer's credit. For this, I'll give you after sales maintenance. And how you decide which group gonna do what? You basically run the program and say that, oh, by region, by different situation, what do I see? So for example, if we look at the program 4, okay, and this time I will do 3 or 4. Let me do 3. And this time, I'm basically said that, oh, I would like to run this for group 1, and then I only want to check, okay, how much the risk ratio increase or decrease by adding 1 groups in. So here, I have different drop curves. Technically speaking, how many things you can do? Can you add education as, we can consider this as kind of like a corrections mechanism. And usually, for example, say, people, I don't know if it's true, saying recession is coming, okay? Twitter, high-tech Facebook, high-tech company, eBay, online sales is dropping. High-tech company are laying off people. And so there are a lot of potential problems, right? I will have a lot of company belly up, or a lot of people gonna file bankruptcy. And if you're the president, you worry. Of course you worry, because it's gonna hurt in the elections 2 years from now. So what will be a good thing to do? Give extra on-the-job training, or extra training. I will teach anybody want to learn Python, a programming discount, or free education for those people want to learn R from SAS, or doing something. And you select region by region, and then what will be the Congress we're gonna ask? Okay, what's the potential benefit? How much risk ratio can we reduce for the bankruptcy? And what will be the other thing they will ask? Well, do all those education, training, compensation, or even give coupon for certain things. Cost money, right? So the Congress will basically start as risk-benefit evaluation. how much you're gonna spend and how much risk ratio you're gonna reduce. So the comparison here is not based on, how much CVAR person by person, one individual at a time. It's always about how much money you can how much budget you can get out of this, and by doing this, you need to come up with a justification and said how much risk ratio I can reduce, and usually people not gonna do this. Let me go back to the output and not G-plot. Okay, let me find a different one. Okay, is when you run this, a lot of time, what people are really interested in is the PHREG here. Oh, here we go. You will see the hazard ratio, and you want to see hazard ratio increase or decrease by how much. You follow me? So the things here is always the same. Oh, I reduce the conflict, okay? Or I increase the GDP, okay? And if you increase the GDP, and you can tell the income, or I improve the growth, and improve the growth will reduce the risk, or you increase the hazard function up and down, and all you care about is this, okay? For that kind of stuff, every things I add in, okay, what will be the respond to my hazard ratio? Okay, so what will be the homework like? The homework will be the following. Basically, I'll say, here are the things I would like you to change. By region, by certain things, I will let you add populations or reduce population. I'll let you add growth or change, reduce growth. I know this is science fiction, but since I don't have real data, but all I care about is every time when you do something, you're doing it nitpicking. You don't do it for everybody, okay? This is always divide and conquer. You don't give, for example, I love to use this example in the old days, is, I will give extra 2 hours support for homework, tutor time, or right now we don't have TA money, but if say I'll provide a tutor, TA money to help you guys do homework, okay? Do I really need to do it for everybody, or I can only need to do it for those students that potentially, they're at risk, but then they're not at major risk? So in other words, is that if I know the student gonna get F, that region, no matter what, gonna be in big trouble. I won't add any more money in there because it's a waste. I think you probably, read sometimes the deep report from PBS or from Rand Institute or Brooklyn Institute. They talk about the same things. United States provide foreign aid to certain regions, to certain foreign leader in doing something. It just wastes tons of money. Nothing you can gain or get benefit out of it. But there are certain regions, that you provide education, you provide training, you provide clean water. Suddenly the living standard changed, and then there are a lot of good things will happen. And you know that if you don't add those things in, the risk ratio gets some domino effect. And because of economic is unstable, politicians is in trouble, and military step in, have a military coup, all kinds of disaster happen. and it's bad for the whole things. So if I would say this, insurance is a long-term policy, okay? And let me, first, you understand how to use PHREG in a competing risk now, right? You monkey around and say, I'll give this only to certain people. It's always a bunch of if statement. If you have this condition, I'm gonna do this to you. And then what you want is you want to reduce the risk ratio. But politically or insurance company, usually they're talking about this, reliability or this, they usually say the following, okay? You will have a green zone. And then you'll have a yellow zone. Oh, sorry, green zone should be here. And then you will have a red zone. Okay? And usually you care about, okay, severity, insert text box. Severity, and frequency. Okay? And if something happens all the time and is very, very dangerous, very severe, and with high severity and high frequency, I don't care, okay? You can put frequency here or frequency here. That's the red zone you should avoid. Okay? This is what you should avoid. Okay? And then if it's high severity and low frequency, in this area, usually you will buy insurance. Okay? So this is the zone you will play with. High severity, you have it? Yeah.
That's not similar to this before.
Huh?
That's like similar to this before.
That's my nose or your nose?
It's something else. It's just
Okay.
same
Yeah.
line.
Yeah. And then if the high frequency and low severity, okay, this is usually the engineering solution. Okay? And so basically this is the area. Your VAR will tell you, forget about it. Don't play with this. In this area, this is a PROC live test. PROC live regression. Calculate your CVAR, your live table. This is the area PHREG, competing risk. What are you gonna do? You wanna do something about it to reduce the risk. Finally, the green zone, shut up, don't do anything. If you want to do something, just make them happy. You don't need to spend money on the engineering part, and you don't need to buy insurance because it's low risk, low severity. And of course, now what you really need to figure out strategically is what kind of business you have. If you have a large green zone, stay in that business. If you have a business look like this, you know, drop, go up, stay away from the business, you need to change career quick, because that's too dangerous. And of course, another things could happen is what? For a lot of company, or a lot of situations, it's something like this. Okay? There are not, this is industrial nations. All the engineering solution already figured out. So there are inconvenience here, inconvenience there, but people take a lot of risk on high severity activity. And, you with a lot of startup company, who knows what will happen, then insurance business becomes very, very big. And the question is, do you think we should take risk as a country? Yes. If nobody take risk, we're gonna die down. The business is gonna collapse. So the question really becomes, do I have enough insurance money to cover all kinds of risk business? And that is the nature of PHREG. Here, engineering solution area, okay? Let me just change the color. Okay, so I will say this is also, I'll do Prague, light reg, to figure out how much CVAR policy I can cover in here. I will do PHREG, proportional hazard model for competing risk. And for this, of course, you probably just do live test. It's good enough to tell, hey, this is horrible things. Run, don't play. Okay? You said you have a homework due tonight, right? After that, let me figure out a couple PHREG game to let you guys play. And pretty much it's alternate either the data or the code I already give you. And I hope you can visualize what's going on. Okay? So we're done today. Yeah?
So is that going to be the last homework assignment?
I think so. Depends. Yeah. Okay.
Depends on what they make do.
Yeah.